Welcome to Lesson 3, Linear Regression. So far you have been studying scatter plots. You've learned how to identify the correlation coefficient by making an estimate. And today what we're going to do, your success criteria, our objectives, are to create a scatter plot from a data set. You are going to estimate a line of best fit by drawing one in, and then write an equation for that line of best fit manually. You're going to use 2 points, find the slope, plug 1 point back in to find the y-intercept. And then you will also estimate the correlation coefficient, which you've already been working on. Then, once you have your equation and your correlation coefficient, we're going to go ahead and use technology, an online graphing calculator, to compare your estimate to what's really actual. Here we have a situation where we've collected data. So in business, you will often collect data on different things in order to see how effective practices and procedures that you put in place are. In this example, we wanted to compare the number of iPads sold with the amount of online sales over a 6-month period. In other words, we want to see if when more people buy iPads, more people start to purchase things online. Is there a correlation? So we've collected some data. Notice that the number of iPads sold is in thousands and the dollar amount of online sales is in 10,000s. Okay, let's go ahead and create our scatter plot with this data. Our number of iPads sold will be our independent variable. That will be on our x-axis. We're wanting to see if online sales are increased or decreased because of this. So online sales is our dependent variable, and that will be on the y-axis. Okay, so what I've done is I've created my graph. I've made sure to include my labels, number of iPads, online sales, and then given it a title, online sales compared to number of iPads. I've taken each of these points and I've made a dot here. I plotted that point. So I've got 6.5, 5.5. You can see that is right here. 4.0 and 3.5 is right here, and so on. So now what do I do once I've made my scatter plot? Well, the next step said, estimate your line of best fit. When I draw in my line of best fits, what I want to do is make sure that I take into account an average of all these points. So in other words, the amount of points on the left of my line and the amount of points on the right of my line should be about the same. We need to take into account the distance that those points are away from my line as well. So if I was going to draw in my line, maybe it would look something like this. And again, remember, this is an estimate, so it's not going to be perfect. On this top part, I have 1, 2, 3, 4 dots almost on the line, but just above them. On the bottom half, I have 2 dots, but they're a little farther away from the line. I probably could have made my line go a little bit higher, but that's a pretty close estimate. So I'm going to use that as my line of best fit. That's my estimate. Now what I want to do is create an equation for that line. When I'm doing an equation for the line, I need to make sure that I ignore the other dots that I've plotted. All I care about is this line. This is my trend line. This is telling me what I need to see as far as in the future and what's going to happen. So I need to pick 2 dots that are on this line. Sometimes the dots that I've already plotted might be on the line. Like this one is pretty close. So maybe we can use this one for 1. And then if I continue on down and look for additional dots, maybe I'll use this one right here. So I'll use those 2 dots when I'm doing my line of best fit. Always when you do your dots, identify what you've used. This is at 8, 6.5. And this dot down here is at 5.5, 4.5. Okay, now that I've identified my points, I'm ready to create my line of best fit. So the first thing I need to do is find my slope. Remember that a line of best fit is in the form y equals mx plus b. My slope is the m portion. Remember that slope is the change of y over the change of x. So I'm going to pick one of my y points. I'll use 6.5 and subtract the 4.5 and then put that over my change of x. So that would be 8 minus 5.5. And then I just need to simplify. So that's going to be 2 over 2.5. Since that's a fraction that has a decimal, I would go ahead and put this in my calculator and determine what that is as a decimal instead of this improper type fraction. So I'm going to do 2 divided by 2.5 and come up with 0.8. So I know then that the slope of this line is 0.8. Let's move on to step 2. Step 2, I need to find b. I found m, my slope, but now I need to find my y-intercept. So the way we do it is we pick a point that we used, either the 8 and the 6.5, or the 5.5 and the 4.5, and we're going to plug that in for x and y, along with the slope that we just found. I'll go ahead and use the 8 and the 6.5 and plug that in. So I would have 6.5 is equal to 0.8 times 8 plus b. Now when I simplify all this, I'll be able to find my y-intercept. So first thing is I would multiply the 0.8 times the 8 to get 6.4. Then in order to solve for b, I would need to subtract 6.4 from both sides. That would leave me with a y-intercept of 0.1. And if you look at where this line goes, if I had raised it up a little bit, maybe it's hard to tell because this again is an estimate, but you can see that where this line intersects the y-axis is somewhat close to 0.1, so I'm probably okay with my formula. So the line of best fit is going to be y equals 0.8x plus 0.1. Now before I compare this to what I get on my calculator, I need to estimate my correlation coefficient. Well, we know it's positive because it's going in a positive trend here. We have a positive correlation. Now let's look at how close these dots are to my line of best fit. They are very close. So I'm going to estimate my correlation coefficient to be 0.9. Remember that 1 is a perfect correlation, meaning that every point is on my line. This is not quite the case, but they are still very closely clustered to the line. Okay, let's go ahead and go to our calculator and see how close we were. Here's our calculator. When you click on the link, you'll want to choose Statistics Calculator in order to have the calculator calculate your line of best fit or regression analysis, and then also come up with the correlation coefficient. Once we click on the statistics calculator, we end up with a screen that looks like this. This isn't quite where we want to be. We want to go to regression analysis. So we'll click on regression analysis, and then you'll get a screen where you can input your coordinates. Notice that I've already inputted them. 6.5, 5.5. So my x value is 6.5, my y value, and this is the function notation, is 5.5. So I've gone through and I've entered in all my points. Okay, once you've finished with that, you've entered in all your points, you can go down here to the bottom, we'll scoot that over, and you'll see a button that says Analyze. So let's go ahead and click on that button and see what happens. Notice we end up with a regression equation as well as a coefficient of correlation, which is our correlation coefficient. So let's see how close we were. Well, notice we have 0.8x and they have 0.0145. We have a y, oops, this is reversed. I didn't notice that. Notice they have 0.7973, which rounds to 0.8x, which is very close to ours. For our y-intercept, they have 0.0145 and we have 0.1. So you can see that our estimate by hand of our line of best fit was actually very close. Now remember, what did we say for the correlation coefficient? We said r equals -9, and they got r equals 0.9. And they said that the coefficient of correlation, which is the same thing, is 0.982. So very close to 1, and we had a pretty good estimate. Let's see what theirs looks like graphed. So So let's move this over again. And if we scroll down again to the bottom, it says plot graph. Let's go ahead and plot the graph. Now we can compare how does their line look compared to our line. And it's kind of hard to fit these both in here. So if we look, see if we can shrink this up a little bit. We can see that they're actually quite close. And we know that this would be the case because our equations are very close as well. So you'll notice that on their line they have these same 2 points below the line, and that this point is really a little closer to the line. And so it's actually quite close to what we have created ourselves. Okay, now that we've finished that, we've made a good equation and we've calculated a very nice correlation coefficient. It will be up to you to try some problems on your own. So, in order to be successful with this lesson, you should know how to create a scatter plot from a data set. You should be able to draw in and estimate a line of best fit that takes into account an average of your points. You should also be able to manually write an equation for the line of best fit using your 2 points, as well as estimate the correlation coefficient by seeing how close your points are to your line. Finally, you should then be able to use technology with a link I provide to compare your estimate to the actual.